Yeah. Hello, everyone, and I'm very happy to have you tonight with us. And my name is Song Yu. You can also call me Daniel if it's easier for you. And I'm from China. And currently, I'm working as a associate software engineer at Rakuten Asia. And before we start, I want to express my gratitude to Rakuten and also JuniorDevSG for this amazing opportunity to allow me to share some knowledge and insights on AI applications with you. And today my topic is about orchestrating large language model agents with supervision with the LangGraph framework. Yeah, and hopefully Hannah's presentation has given you some idea about what LangChain is about and how can we build LLM applications with it. And yeah, so this will be the agenda for today. Firstly, I will be giving you a quick demo on what kind of applications we can build with LangGraph. Then I'll talk about the motivation of using LangGraph. Then we'll be going through this agent supervision architecture and also what is LangGraph all about and how do we actually use LangGraph to implement something. And finally, we'll be talking about some future explorations as well as some questions you may have. So before we dive into the boring part, let's see a quick demo on what kind of applications we can build with LangGraph. So here you can see my screen, right? So this is a very simple chatbot. And so the first thing I want to ask about the chatbot is, I believe that all of you have used this kind of chatbot like ChatGPT or a DeepSeek or something else. You may have encountered the issue where the AI can give you falsifiable or wrong information because of the hallucination, because we know that the AI models are trained on history data. And if you ask something that is up to date, it might not have the ability to get that information correctly and respond to you. But nowadays, we are able to actually equip the AI models with tools like web search so that it can actually retrieve the data on the fly and it can return the correct information to you. So actually, does anyone watch Formula One? Okay. Actually, last week, there's a race in Australia. So let's ask the chatbot, who won the race? So yeah, who won the F1 2025 Australia Grand Prix? So it's a very up-to-date information. So if we check on Google, it's Lando Norris, the winner, and then followed by Max Verstappen and then George Russell. But can our AI chatbot get this information correct? Yes, it can. It says Lando Norris won the 2025 Australian Grand Prix. Okay, good. So then I actually want to ask for some very specific definitions or informations that can be previously we can only find on websites like Wikipedia. So for example, what's the definition of AGI? Yeah, so this is also not a very recent concept, but still it's better that actually we reference from trustworthy websites like Wikipedia to find those information instead of asking AI, which can give hallucination and wrong answers. And also, I'm not sure if you have tried. Actually, the reason that Hannah brings the topic about calculator is that if you ask very complex mathematical questions to the AI, they can actually give you a wrong answer if you have tried models like GPT 3.5, because the way that AI models generate the answers is that they convert everything into tokens, which are basically vectors, and they predict the next word, next tokens with probability. But mathematical questions are not so easy to get answered with just predictions in probability. So we really need the tools like calculator to really get the answers correct. So let me ask a question about maybe what is this question? So hopefully the AI can also get it correct. Okay, now I respond with probably the correct answer. better than the GPT 3.5. And lastly, I believe that most of us are developers, and we do use AI for a lot of general questions about coding. So let's ask maybe how to create packages in Python. Yeah, so very quickly it can give me the answer. So far nothing special, right? But if I tell you, actually all these answers are generated by 4 different LLMs. Is that amazing? Okay, let me show you. So actually in my backend console, the first answer about the F1 result is generated by this agent called Chat and Search Agent, which is an agent that has the access to the web search tool. The second one about the definition of AGI is generated by an agent called Wiki Agent, which has access to the Wikipedia. And then the third answer about some mathematical questions is generated by this agent called Math Agent, which has access to this calculator tool. And then the last one, we are asking about some programming or coding questions, is answered by this Code Agent. So you can see that with this single interface, we're able to actually get answers from all the different agents or different models. And this entire application is actually built very easily with LangGraph. So then I will be talking about how can we actually build this, and hopefully you can build it, do it yourselves after this presentation. So yeah, let's go back to the presentation. So let's first talk about why we want to use LangGraph for this kind of user experience or this kind of app we want to build. So firstly is that we want to actually augment the information retrieval experience with the power of AI. So actually, since the introduction of ChatGPT, many people don't actually use, including myself, Stack Overflow that much, because now the AIs can easily give us answers on general knowledge for very basic questions and for some facts that happens like a few years ago. But if we ask something recent, it might give us the wrong answers. So that's why we need to introduce tools like web search. And so we actually want to provide a very universal user interface where we can allow the users to access to diverse information types and sources within a single interface. And also, we understand that different LLMs has actually different unique strengths. Like, for example, the cloud model from Anthropic is more capable in coding, and DeepSeek is a very the R1 model is very good in reasoning, and ChatGPT, their GPT like 4.0 model is good for coding tools. Yeah, so we understand that these different LLMs actually have their unique strengths. So we actually want to combine them and ensure that it can respond with the correct model, with the correct answer that is contextually relevant to the user's answers. And finally, we want to actually easily onboard new large language models, because every 2 or 3 months, there will be another new model out on the market, right? So how can we build a framework that can easily adopt to use the new models? So that's why we want to choose LangGraph for this purpose. Yeah, so, and the framework I'm talking about today is called LangGraph. It's a orchestration framework. So if we use an analogy, LangChain is like Docker, and LangGraph is like Kubernetes. So you can build multiple chains and orchestrate them with LangGraph, which is really powerful. Yeah, so what is LangGraph about? It's an open source library for building a stateful and multi-actor application with large language models. And it is developed by the same company who developed LangChain. It is useful to create agent and multi-agent workflows by modeling the workflows as graphs, basically nodes and edges. We connect them so we can easily describe the workflow that we want. And it can be actually used independently of LangChain. So if you are currently using any other large language frameworks, this is also usable for you to try out. And This LangGraph is currently implemented in TypeScript, JavaScript, and also Python. So whether you want to build some web applications like what I did with a chatbot, or you want to build some backend to serve some APIs, you can easily use these supported languages. And the core benefits of LangGraph framework is that it supports cycles. So as what Hannah just presented, I believe the most use case of LangChain is linear. So it's basically a sequential order. You want to execute stuff step by step. But with LangGraph, we are able to create actually cycles to have like continuous operations. And it has a very good controllability where you can define all the states and nodes and edges in this graph. So it offers this fine-grained control. You can define everything in code so that it is more predictable. And finally, its persistence. It has the built-in persistence for us to have the memory features like what Hannah just showed, so that the LLM is better aware of the past history of our conversation, so it can generate better answers for you. Yeah, and then it's about this agent supervision architecture. Yeah, so what is this architecture about? Actually, it's quite similar to what Hannah just shared as the router chain. So basically, to understand it better, we use an analogy. So imagine you are running a consultancy business and you hire many experts, and each are specialized in some different knowledge domains. Like some are, for example, coding experts. Some are sales experts. So you are the supervisor, and your duty is to basically understand your client's needs and assign that particular request from your client to the correct expert, so that the expert can handle the task for the client. And if we go to LangGraph with this architecture, it's actually very, very similar. So basically, we create nodes. One node is called supervisor, where it directly interacts with the user and understand the user's request. And its duty is basically to route the correct user's request to the agent nodes that are basically the experts specialized in some knowledge domains. Yeah, so if we go back to the picture, isn't this very similar? Yeah, so with this knowledge in mind, how do we actually implement this whole, for example, this chatbot that I built with LangGraph? So first of all, we want to select some models, right? So it's large language model application. We want to use models. Okay, yeah. So this architecture requires the LLMs to have the tool calling functionality, because router is essentially a tool. So the supervisor will need to access the router to correctly assign the task to the correct agent. And for that purpose, we want to use the GPT-4o Mini for the supervisor, because GPT-4o Mini is actually reasonably good in reasoning to understand your user's request and understand the system prompt that you provide to it. It is also very fast because we don't want to spend too much time on deciding which agent to use. And also, it's very cost efficient. The price for the tokens is much lower than other more capable or complex models. But for the worker agents, because we want to get the users the most correct or the most useful information, so we may want to consider to use some better models like GPT-4o. But in this example, I'm just using the models from OpenAI. This architecture or this flow allows you to use any models you want, like whether it can be the DeepSeek model that you deployed locally on your machine, or it can be Cloud from Anthropic, it can be Gemini from Google, anything. We are just using OpenAI's models for demo purpose. Yeah. Okay. And for the tech stack for the chatbot I used, is mostly because it's basically a web application. So it's very close to the front-end tech stack. Like we use Node.js and TypeScript and Next.js to handle the application itself. And we use Vercel's AI SDK to build the bridge between the front-end UI and also the LLMs. And then we use the LangGraph to create the whole routing mechanism. And of course, we are using OpenAI's model, so we are using the OpenAI library to invoke the LLMs. Yeah, so With LangGraph, we can easily describe the supervisor and agents in code with the following steps. Actually, only 4 steps, pretty easy. Firstly, we want to define the state and create an empty graph. And then we define all the nodes, like these circles, rectangles in the graph. And then we connect them with with edges to define their relationship and the transition between different nodes. And also, we need to add an entry point where the user interact with. And also, finally, with this graph and nodes connected, we just use the compile method. And finally, it is able to be invoked to give you the final answers. So let's go through the steps one by one. So the first step is to define the state and create an empty graph. So to build a LangGraph application, the first thing you need to do is to define a state. Here we call it agent state. So it is basically just a simple object that is passed between nodes to exchange the information and understand which step you are currently in this application. It includes the information on the basic structure of the graph so that each node is aware where we are. And it also allows you to define a reducer method, which is basically a function that specifies how each node should update the state, update its object to pass the latest information to the next one. And here we define 2 important fields. One is called messages. It's basically the text, the chat conversation we have. And then there's another property called next. It's basically deciding, okay, who should respond next? Should it go back to the supervisor? Should it go to the math agent, or should it go to the web search agent? So next is basically holding this information to let the graph understand which agent or which step should we take next. Yeah, and then we want to initialize an empty graph. So graph nodes, they communicate by writing and reading the shared state object that we just discussed earlier, and so that we need to pass the agent state to the graph. And then we want to define the graph nodes. And firstly, we want to define the supervisor. So the supervisor is responsible for routing your user's requests, right? So it's pretty simple as well. Firstly, we want to define what are the members available. So basically, which agent nodes that I can route to. For example, it can be a chat agent, which is for general chat purpose. It can be a code agent, which is capable to answer complex coding questions. And it can also be math agent, which is a math expert to give you the best mathematical question answers. And we will put some system prompt to the supervisor. So basically, I'm saying that, okay, you are the supervisor. You should understand the user's request. You should assign the task to the next most reasonable agent that is capable to answer the user's question, which is quite straightforward. It's in plain text. And finally, we need to give this supervisor a routing tool. So this is actually the tool that the supervisor used to decide the next node that it should transition to. Yeah, and we will also need to build a simple supervisor chain where it can function as what Hannah just shared, have multiple stages of input and output that are chained together. Firstly, it has to format the prompt because the supervisor needs the system prompt to understand the routing task. Then we want to give it the routing tool so that with the input and user's prompt, it can decide the next route to use. And then we want to parse the output from the LLM and then format it into JSON so that we get the answer of the result of the routing. So it will basically show you something like next chat search agent, next code agent. So this will be the output. And with this output, we are able to understand which agent node it should transition next. Yeah. And with the supervisor ready, we then will go ahead to define the graph nodes, basically the agents. And each agent can have their own tools. For example, the web search agent has the access to a web API, and the wiki agent has the access to the wiki tool to download information from Wikipedia. And also, again, the math agent can use the calculator to calculate the answers based on your request. And here we are using a built-in function called create React agent. This React is not the front-end framework React, but reason and acting. So it means that it can understand your request based on the prompt input and perform actions based on its understanding. So here we provide the tools and also another system message to tell this expert or this agent what you should do. So for example, I'm telling that this should be a math expert. So it understands, okay, I am handling mathematical questions. I should probably use the calculator to answer my user's question. Yeah. And with that definition, we can create a node called agent node where, you know that actually in LangGraph, the nodes are represented as functions, which are pretty straightforward and easy to understand. And this function will just invoke the LLM, basically the GPT-4o, with the current state as the input. Basically, the state holds the past history of the conversation. And then it processes the React agent's output and format it into a new state that can then be passed to the next stage. It can be like returning directly to the user, or it can be in other stages of the graph. Yeah. And finally, we defined all the agents and the nodes and also the supervisor node. The next step is to basically connect all of them. Firstly, I'm adding the supervisor chain as the supervisor node to the graph. Then I can add all the agents available, the agent node, and also add an edge from the agent to end. And so end means basically we want to stop the conversation so that once the agent gets the answer, we want to directly return it to the user. And finally, we want to add a conditional edge. Basically, this is the part that routing happens. So we give the supervisor a link to all the next possible agents so that it understands, okay, I can jump to that agent state conditionally based on whatever the routing decision I have made as a supervisor. And finally, we add the entry point. It's basically the starting point. The user's response will be directly forwarded to the supervisor to start all this routing mechanism and also the question answering. Yeah, and finally, with the graph filled with the edges and nodes, we can finally compile it and then invoke it with the methods that are built in, like the stream events, so that we can get the answers by streaming. And it works exactly in the same way that ChatGPT works, where you can see your answers get generated in real time. Yeah, so that's quite straightforward, right? So you only need 4 steps to build this chatbot with this routing agent supervision architecture. And let's now talk about some future explorations with this LangGraph and also our application built. So firstly, we want to actually explore more integration with open source large language models instead of just the OpenAI GPT models, because I believe that you all know that actually nowadays many open source models have better capability in reasoning, in mathematical, in coding questions than the OpenAI's model. But OpenAI did package all of their models with very easy to use and intuitive APIs. But why not explore the open source LLMs? They are free. We can just do self-deployment on our own servers. We have better control. We can fine-tune on our own data. So we can build this entire solution for our own products. So let's say you're building some coding assistant. You can build multiple agents that, for example, one can connect to Stack Overflow to give you the whole human answers. One can connect to Google Search. One can connect to whatever database you have so that it can answer you all the best questions. And open source large language models are already capable as the GPT-4o models that we use today. And we will also like to explore some other architecture patterns available in LangGraph. Today, it's just agent supervision, basically routing. your request to the correct LLMs, so that you can add infinite number of agents to your chatbot, and it can answer the correct questions and answers to your user. But there are also some other patterns like collaboration. So basically, the agents themselves can talk to each other to do multi-stage reasoning and finally compile all the output to the user. So if you are trying to build some research tools that requires several steps of reasoning and tool calling to search the latest information on the internet, this kind of pattern might be suitable for your use case. And finally, we may want to create some generative UI to display the search results in UI components instead of just text, which might be easier if you want to build a product for maybe for kids, for elderly. The UI will be much easier to read compared to just text. And finally is that we actually want to consider optimizing the cost for production use. If we want to actually serve this in public traffic, you know that actually LLMs are not cheap, not at all. So we will really need to consider either do self-hosting of open source models, or we try to think of some mechanism that can save us some cost while serving our users' requests the best way. Yeah, so that's basically my presentation today. Let's quickly conclude. Firstly, we went through a quick demo of the chatbot that can be built with LangGraph. Then we discuss about the agent supervision architecture. And finally, what is LangGraph all about? Why do we use this open source framework? And finally, the implementation details of creating this chatbot with the supervision graph and also the future explorations. So also maybe in the interest of time, we can answer your questions later. And yeah, feel free to connect with me on LinkedIn or GitHub. Yeah, that's my presentation. Thank you so much.